Welcome to this comprehensive guide on C-sharp scriptable objects and data-driven architecture in Unity, designed specifically for beginners. We'll explore how these powerful tools can enhance your game development. Scriptable objects are special Unity assets that store data independently of scene objects, meaning they are not attached to game objects like monobehaviors. They exist purely as data containers within your project. They exist as assets directly within your project, providing a flexible way to manage various types of game data. This allows for a clear separation between your game's logic and its underlying information. One key benefit is their role as data containers, making it much easier for designers to manage game data without needing to write code. This empowers non-programmers to directly influence game parameters. Scriptable objects also promote memory efficiency by allowing data to be shared across multiple instances, significantly reducing memory overhead. Instead of duplicating data, they reference a single, central source. They enhance modularity by separating data from logic, leading to cleaner, more organized code and improved testability. This clear division makes your project easier to understand and maintain. This separation also means artists and designers can configure game logic directly in the Unity editor without needing to touch the underlying code. They can adjust values and settings through intuitive interfaces. Furthermore, data stored in scriptable objects persist automatically between scene loads, ensuring consistency throughout your game. This is crucial for maintaining game state and settings across different levels. Their reusability is immense. The same scriptable object can be used for multiple items of the same type, ensuring consistency and reducing redundancy. For example, one weapon data can define properties for all swords. You should use scriptable objects for storing data that doesn't belong to a specific scene, such as global game settings, item definitions, or character statistics. They are perfect for defining static game elements. They are ideal for sharing data between multiple scripts or objects, and for managing global data accessible from anywhere in the scene, avoiding the drawbacks of static variables. This provides a safer and more organized approach. Consider them for configuring static gameplay values like item stats, NPC stats, or character dialogue. This allows for easy balancing and modification of game mechanics without recompiling. When comparing scriptable objects to monobehaviors, remember that monobehaviors require a game object and transform, leading to more memory overhead. Each monobehavior instance carries this additional baggage. Monobehaviors are primarily for game logic and execute within the scene, while scriptable objects are purely for storing data and do not have lifecycle methods like start or update. This defines their distinct roles. Now, let's delve into data-driven design, or DDD, a software approach where a program's behavior is governed by external data rather than hard-coded logic. This paradigm shifts the focus from imperative code. In DDD, your code provides generic mechanisms for processing data, while the specifics of what to do or how to behave are defined within data files. This allows for highly flexible and configurable systems. This approach heavily emphasizes clear data input, transformation, and output processes. Understanding these stages is crucial for designing robust and predictable data flows. A key principle of DDD is to design your data structures and transformations before you even start coding. This upfront planning ensures that your data model is sound and effective. It also focuses on efficient memory usage by structuring data for optimal CPU access. This means arranging data so the processor can retrieve and manipulate it with minimal overhead. Another principle is using blittable data types, which can be copied directly without complex processing of pointers or references. These types allow for fast and direct memory operations. Crucially, DDD advocates for separating data from logic, keeping your game engine generic and thin. This separation ensures your core engine remains adaptable and reusable. The benefits of a data-driven architecture are numerous, starting with increased flexibility, allowing you to modify game content without altering the underlying code. This empowers rapid iteration. It offers excellent scalability, making it easy to extend your game by adding new data types without modifying existing code. This means your game can grow and evolve without extensive refactoring. This approach also leads to a cleaner, more maintainable code base that can scale effectively with your project. A well-structured data-driven system simplifies debugging and future development. Collaboration is greatly improved as it empowers designers to iterate on content independently. Designers can tweak values and create new content without needing a programmer. Finally, data-oriented design can significantly improve performance by optimizing memory access and enabling data parallelism. This allows your game to process large amounts of data more efficiently. Scriptable objects are crucial for enabling data-driven architecture, serving as external data sources that directly drive your game logic. They act as the bridge between data definitions and runtime behavior. They allow you to define game elements like items, enemies, or abilities as distinct data assets. Each asset can encapsulate all necessary properties for a specific game entity. Your game code then reads and processes this data to create dynamic and highly configurable gameplay experiences. You can change game balance or introduce new features by modifying data assets. Now, let's walk through the practical steps of creating and using a scriptable object in Unity. This hands-on guide will demonstrate how to implement these concepts in your own projects. First, create a new C# script in your Unity project, for example, named Item Data. This script will serve as the blueprint for your custom data asset. Open the script and change its inheritance from monobehavior to scriptable object. This crucial step transforms it from a component into a pure data asset. Add the Create Asset menu attribute above the class definition to enable asset creation directly from the Unity editor. This attribute specifies the menu path and default file name. Next, define public variables within your scriptable object script to store the data you wish to manage, such as item name, icon, and value. These variables will hold the specific properties of your game items. Use appropriate data types for each variable, like string for names, sprite for icons, and int for numerical values. Selecting the correct type ensures data integrity and efficient memory usage. For private variables you want to expose in the inspector, use the serialize field attribute. This allows you to keep your variables encapsulated while still making them editable in the Unity editor. Now, to create a scriptable object asset, right-click in your project window in Unity and select Create, Inventory, Item. This action utilizes the Create Asset menu attribute you defined. This action generates a new asset in your project based on your item data scriptable object script. It's an instance of your data blueprint, ready to be populated with specific values. Rename this asset to something descriptive, like sort_data, to easily identify its purpose. Clear naming conventions are vital for maintaining an organized project. Select your newly created scriptable object asset, sort_data, in the project window. This will display its properties in the inspector, allowing you to configure its specific data. In the inspector window, you can now populate the data fields you defined in your script. This is where you assign the unique characteristics to your sort_data asset. Assign values, drag and drop sprites, and configure all the necessary data as required for your item. For example, set the item name to Excalibur, assign a sword icon, and give it a value of 100. To use this data, create a monobehavior script, for instance, item display, to show the scriptable object's data in your game. This script will be responsible for reading and presenting the data. Declare a public variable of your scriptable object type, item data, within this item display script. This variable will serve as a reference to the specific scriptable object asset you want to display. Also, add references to UI elements like text for the item name and image for the item icon. These will be the visual components that display the data from your scriptable object. In the start method, check if item data is assigned. Then update the UI elements with the data from your scriptable object. This ensures your UI is populated with the correct information when the game starts. Now, create a game object in your scene or select an existing one and attach the item display script to it. This game object will be the visual representation of your item in the game world. In the inspector for the item display script, drag and drop your sort_data scriptable object asset into the item data variable slot. This links your monobehavior to the specific data asset. Connect the item name text and item icon image fields to the corresponding text and image components in your scene's UI. This establishes the visual connection between your script and the UI elements. With everything connected, You can now access the data stored in the scriptable object through the item data variable in your item display script. This allows your game to dynamically display item information. This data can then be used to update UI, modify game logic, or perform any other actions driven by your defined data. For instance, character stats could be updated based on an equipped item's data. Let's cover some essential tips and best practices for working with scriptable objects. Adhering to these guidelines will help you maintain a clean and efficient project. Always use clear and consistent naming conventions for both your scriptable object scripts and their corresponding assets. This makes your project easier to navigate and understand. Organize your scriptable object assets within a dedicated folder structure to keep your project tidy and easy to navigate. A well-structured project saves time and reduces confusion. Primarily use scriptable objects for read-only data. If you need to modify data at runtime, consider a separate data storage method and reference it from a scriptable object. This prevents unintended changes. For a better designer experience, create custom editors to improve the inspector interface for your scriptable objects. Custom editors can provide intuitive controls and visual feedback. Finally, remember to combine scriptable objects for data storage with monobehaviors for implementing the game logic that utilizes that data. This symbiotic relationship forms the backbone of a robust architecture. By following these principles, you can build robust, flexible, and maintainable games in Unity. These practices will lead to more scalable and easier to manage projects. Thank you for watching, and happy coding. We hope this guide has provided valuable insights into scriptable objects and data-driven design.